Hello children and welcome to this session today. Children, we all understand the importance of time. Day in and day out, our mothers are after our lives. You're getting late. Hurry up. Look at the time. Look at the clock. Right? So time is of essence in our life. Now today we are going to understand two important physical concepts. Chapter number 13, Motion and Time. In this chapter, we are going to understand some things about measurement, some things about motion and their relation with time. So let's begin. So we have learnt in the previous lessons that a comparison of any quantity is known as measurement. And why do we need measurement? We need measurement to understand how many kilograms of food we are taking from the vendor, fruits, vegetables, etc. We need to understand if we are traveling from one city to another, how much kilometers do we need to travel, how much time it is going to take to cover that distance. So, measurement is an inseparable part of our everyday life. And also, we have learnt about standard units in the previous chapter. We know that in earlier times, a hand span, a foot span, all these things were used as measuring units. But now we stick to standard units. What are these standard units? They are centimeter, they are second, etc. Now, why are these standard units important? They are important so that there is uniformity of measurement everywhere around the world. Whether you are sitting in Delhi or you are sitting in London, your measurement should be same. The standard unit for measuring distance is meter. Standard unit to measure mass is kilogram. Temperature is Kelvin. And second is the standard unit of measurement of time. Now, let's understand the measurement of time. Measurement of time becomes very important over all other units because time, as I said, is of essence. There are many units. For example, we all know that 60 seconds is equal to 1 minute. 60 minutes is equal to 1 hour. Then 24 hours make a day. 7 days make 1 week and 52 weeks make an year, and we can go on and on like this. We know that 10 years make a decade and 100 years makes a century. So this is how time is understood. How do we measure time? So earlier on, when there were no watches, people used to use the concept of sunrise, noon and sunset to understand time. And they used to use sundials. As you can see, this sundial used to cast a shadow that used to move around the dial with the movement of sun in the sky. But once again, this was not very trustworthy. So what was developed? A pendulum was developed. What is this pendulum? Let us understand through a video. All watches and clocks use the principle of periodic motion for measuring time. Any motion that repeats itself after regular intervals of time is called periodic motion. A simple pendulum shows periodic motion. A simple pendulum consists of a metal bob suspended by a long thread from a rigid support. The bob is free to move back and forth. The extreme position of the bob is the maximum distance from the mean position. It is B and C as shown in the figure. Even in your book, there is an experiment which will help you to measure the time period of oscillation using a simple pendulum. Do conduct this experiment. This is a very simple experiment that can be conducted in your classroom itself. Now moving on to stop clocks and stop watches. So from the pendulum clock to stop clock and stop watches, we have come a huge distance, right? So we all know that there is a sports day in our school and the sports teacher uses a stopwatch to estimate the time in which the runner runs, or he also uses it to understand how much time a game has been played. Now, speed and its measurement. What is speed? We all know that when a body moves from position A to B, this change in position is called motion. And this movement will take some time. Now, the distance that is covered in a unit time is known as speed. So, how do you define speed? The distance covered by a body in a unit of time is known as speed. And what is the unit of speed? It is meter per second. In our cars, there is a speedometer that measures the speed at which the car is moving. Now, there is a simple formula to calculate speed. Let us understand this by using the examples from the book itself. Rajesh cycles a distance of 15 km in 45 minutes. Find his speed in kilometer per hour. Distance D travelled by Rajesh is 15 kilometers. Time T is equal to 45 minutes or 45 by 60 hour. Therefore, speed is equal to 15 divided by 45 by 60, which makes it equal to 15 multiplied by 60 by 45, which is equal to 20 km per hour. Answer: speed of Rajesh is 20 km per hour. Example 2. Tejas fighter aircraft reaches a speed of 1500 km per hour. Find the distance travelled by it in 20 minutes. Speed of Tejas is equal to 15 km per hour. Time T is equal to 20 minutes of 20 by 60 hour. 1 hour is equal to 60 minutes. Therefore, distance D is equal to S into T, 1500 into 20 by 60, which is equal to 500 meter. So, these are simple examples to tell you how speed is calculated. Now, we have understood the concept of an object moving from one point to another. Now, let us take another example. For example, there are 4 points A, B, C, D, and all these points are equidistant. Let's take the example of A to B being 10 km apart. Similarly, B to C is 10 km apart and C to D is also 10 km apart. Now, let's take an example of a bus. This bus has to travel all this distance. It is traveling from A to B in 5 minutes. It is traveling B to C in 5 minutes. Again, it is traveling from C to D in 5 minutes. That means it is covering equal distance in equal time. When this kind of a motion takes place, it is known as uniform motion. And uniform motion can be represented on a graph by a straight line. In case the bus in our previous example was covering different distances in different times, then our graph would be something like this. What is it? It is an example of non-uniform motion. Another example of non-uniform motion that we can take here is when a car starts from rest and covers a distance of 25 km in 1 hour, a distance of 20 km in 30 km in the next 2 hours. So here when you draw this graph, you take time on the horizontal axis, you take distance on the vertical axis. So from 0 to 25 km is 1 hour, from 25 to 55 km in the second hour, and thereafter in the third hour. So as you can see, this graph is not a straight line. So this shows non-uniform motion. So in this chapter, children, you have understood the units to measure standard units as well as non-standard units. You have also learned in this chapter how motion and time depend on each other, how non-uniform motion and uniform motion differ from each other. Do attempt the numericals given in your book for practice. Thank you so much for joining us.